This is it. This is where we're finishing notes for all the geometry part A. Let's lock in for, it's only 8 questions, and we're not even going to do 8. Here's what we got. Angle of elevation on the back. Angle of depression. Keep your head up, though. You'll get through this. On the front, angle of elevation. We're talking about when you are, a lot of times, looking up at something or launching something. Sometimes you might see a question like they did a kickoff and the field goal had this angle of elevation. Bottom line is, we got a triangle. And it's a word problem, and we got to make a triangle. At this point, we know how to solve the sides of a triangle. We know how to solve the angles of a triangle. And when it comes to angle of elevation, it's always going to be a nice right angle. So that makes everything perfect. So let's read this. It says, Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. And look, we already got a nice picture, but the whole idea of this is draw your own picture. So we're just going to copy this picture. There's our triangle. It's a right angle in that little corner, and we got a lighthouse. So I'll draw a nice lighthouse. Woo! You guys ever been to a lighthouse?
No. Yeah.
For whatever reason, my mom went through a summer where she just drove us to all these lighthouses, and we just walked up the lighthouse. Wow, this is cool. This one's got stripes. Wow, Mom. Yeah.
There was a portion of social studies where we had to learn about all of them and go visit all of them.
Cool lighthouse, Mom. It's a big, tall one. Wow, cool. Anyways, lighthouses. There we go. Now, we know a couple things about this. We know that the top of the lighthouse is 84 feet tall, which is pretty tall. We also know that the degree here of the little, I don't know, Casey. Is Casey a boy's name, girl's name? I don't know. We'll know. 58. Who cares, right? We'd have to ask Casey to see what they say. We got 58. Okay? But we also know that Casey is 6 feet tall. Now, where the heck does that number go? Is 6 feet the hypotenuse for this question? Casey might be 6 foot. I don't think that 6 foot is all the way from Casey to the lighthouse. 6 does not make any sense right here, right? Does Casey's height mean how far he's standing away from the lighthouse? No. Casey's height is neither one of those numbers. Casey's height is literally just his height, right? It's how tall Casey is. So the question here, who cares? What do we do with that 6? So think about it like this. Is our triangle, because Casey sees out of his eyeballs, right? Does Casey see out of his eyeballs, or does he see out of his toes?
Eyeballs.
He sees out of his eyeballs. So is this triangle that we've made of Casey looking at a 58-degree angle, is this triangle resting on the ground? No, the triangle is like on stilts, right? The triangle is starting, this high in the air, and the triangle is kind of looking like this kind of triangle. I don't know, I'm doing my best, guys, right? So, if the triangle looks like that, and the triangle is 6 feet in the air, what do you got? Sure, go get some water. What are we going to do with this 6 feet? The triangle is floating 6 feet in the air, but the tower here, the lighthouse, is the lighthouse floating 6 feet in the air? No, the lighthouse is on the ground. So what we just figured out is that, do we need to use 84 as this length over here? No. Because we've got this bottom piece that's 6 feet tall, and we don't need those 6 feet. We got to get rid of those 6 feet. We got to subtract those 6 feet. So basically, if these questions didn't have this floating triangle issue, it would be as easy as a normal question where you just do your sine, your cosine, whatever, who cares. But Most of the time, these elevation questions, or on the back, the angle of depression questions, they have to do with this triangle kind of like floating in a way, and you got to do some subtraction. So this 84 is not even a number that we want. What is the true height of this triangle? 78. And where did that 78 come from? 84 minus 6, right? The lighthouse is still 84 feet tall, but when it comes to our right triangle, we are only eye level with 78 and up. Or eye level with 6 up to 78. I don't know, whatever. Okay, at this point, we know that 58 degrees. We know 78, and I guess we could say feet. What does the question want to know? Is the question wondering about the hypotenuse, or is it wondering about this bottom side of our triangle? It says, how far is he standing? So he's standing from the, I guess I should highlight this part too, from the base of the lighthouse. So they want to know how far is this side. And Zay was already doing some of our work for us. If they want to know this side, he said that this is the adjacent side, and that's great work. We just want to make a little sine or cosine or tangent. We know that we're working with adjacent here. What about this side? That's the opposite. Nice job again. And so we got a triangle. That's a right triangle. We got the opposite and adjacent. We want to work with tangent. Tangent blank equals fraction blank over blank. And so what goes where? 58 next to tangent, that's our degrees. It's going to go right there. Nope, not 84. We don't care about 84. We're going with 78 on the top because that's the opposite. And then the x goes on the bottom. We're ready to just type it in. No problem. We go to Desmos. We type tangent 58 equals fraction 78 over x. We get our line. Doesn't let us click on it. Little bit of a remember from yesterday. Dividing by x. Desmos doesn't do dividing by x. Just put it in the front. Now it shows up. Now we can see 48.7. That's the final answer. X equals 48.7. And just because this is a word problem, 48.7 what? Not degrees. Remember, what we just figured out is how far is he standing from the base. Right. 48.7 is how far he's standing away from the lighthouse. All right, let's do one more of these because as much as we've just started, all right, let's do one more. All right, we just got to draw a triangle, and the only difference we did for this whole question is that our guy was 6 feet tall. And so we had to subtract 6 from the lighthouse height because when our guy was looking up at the lighthouse, his height had to be taken away from that lighthouse. Right. Okay, so let's see this one. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. All right, so we got a little triangle. Typically, we just kind of draw a triangle that kind of is in this shape. Thank you for getting that door. Appreciate that. Terrible triangle. I don't know what happened to me. Good enough. We've got our triangle, and we've got that the angle is 17 degrees. And if he is standing 131 feet from the base of the goalpost, how tall is the goalpost? Interesting dilemma she ran into there. Is there any issue that we need to think about for this one? Do we have some sort of subtraction that we need to do? The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. Okay, I think that makes sense to me, right? He's got to make it in the goalpost like this. If he's standing 131 feet away from the base of the goalpost, and we just assume it's a normal goalpost. Okay. I don't think that we need to add anything on or figure anything out. Or to the top of the goalpost bars, that means all the way to top, right? Is that all the way up here? Maybe I drew my picture wrong. I don't really think it makes any difference for our question, but there we go. I think this is how it's supposed to look. Again, doesn't actually change our question, I don't think. I think for this one, we just straight up run a triangle, run a little SOHCAHTOA, and then that's that. For this question, it wants to know how tall is the goalpost. It's trying to figure out this side over here, and that is the opposite. We can put our X over there. And we're dealing with the adjacent here. And so, yeah, it looks like we're going with adjacent again. We just get all this stuff in there. The tangent of 17 equals opposite. We don't know what that is. We can put an X. Adjacent 131. And this one should be even easier.
So what's that right there? What does that say?
The tangent?
No, did that say XO?
So that says X, and then the O is me trying to be short for opposite, because that X is on the opposite side. So I was using that O to make me think O-A TOA. You know what I'm saying? All right, we should be able to just go to Desmos, type this one in. It should be even easier because the X is on the top. Tangent 17 equals X over 131. Heard a few people say the answer is 40.05. I'm going up to 40.1. And what is 40.1? That is 40.1 feet, because that's how tall it is. A lot of times we end up using TOA, we end up using tangent, because measuring the hypotenuse is like the hardest thing to measure in real life. Normally it's a lot easier to measure on the ground for the adjacent. It's a lot easier to measure the opposite for the height of something. It's normally kind of weird to measure the hypotenuse. So we use tangent for both these, whatever, not too big. Let's just flip it over to the back. Angle of depression. This is it for the notes. These are some of the last notes we'll ever take together. That's why we're going to finish with a little bit of depression. Oh God. All right, here we go. We can push through. We're going to come out the other side of this even better, even happier than we were before. I believe in all of you. Here we go. When looking down on an object, an angle of depression is formed by an observer's line of sight and horizontal line. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. So, that seems like craziness to talk about alternate interior angles, right? Here's what's going on. And they have a picture here, but for some reason I just think it's a little bit... If we have a person over here, and this person is looking down this little degree here, this, if we think about parallel lines with a transversal coming across, we end up with the angle of depression right here matching the angle of elevation because these are considered to be alternate interior. They're on the inside of the parallels. They're on the alternate side of the transversal. I don't know how hugely relevant that is, but it is a little geometry fact, right? Fun fact, I guess. So, directions, draw and label diagram. Okay, whatever, we can do that. And just like the first one, we're going to end up using this nice example to help us with our drawing. A lifeguard is sitting on a platform. All right, we're going to have a nice little triangle. And then we can maybe draw a little lifeguard guy. I like their drawing. It looks pretty good. Way more interesting than lighthouses. Boring. Alright, we got our nice little guy on the lifeguard platform. He's going to be looking down on a swimmer. Wow, what a great drawing of that swimmer they have. I don't know that I can recreate that. Oh, this looks great, Mr. Collier. Nice job. I don't know. And let's put some numbers on here. So, if the lifeguard's line of sight is 8 feet above the ground, all right, here's the ground, here's where his eyes are, and that is considered to be 8 feet above. And the angle of depression to the swimmer is 18 degrees. How far away is the swimmer from the lifeguard? So what we're trying to figure out is how far away is this? All right, this is our goal. And here's where a lot of students make their mistake, okay? A lot of students look at this triangle, they see the guy here, and they end up thinking that we should put 18 degrees in this top corner here, right by his eyeballs. But we're not going to put 18 degrees in that corner. We're going to put 18 degrees by the swimmer. And you might be thinking, what the heck? That's kind of weird. Why is the 18, and that handwriting's terrible, sorry. Maybe if I zoom in a little better, it'll redeem me. The reason that the 18 is down here is the same kind of thing we talked about here. His original line of sight is horizontal, right? The lifeguard should be looking straight ahead. And when he tilts his head down 18 degrees, that 18 is actually on this side of the triangle. It's actually outside of the triangle. And so that's why we kind of think about that alternate interior, and that 18 ends up being down by the swimmer. Now, you might be thinking, who really cares where the 18 goes? It does make a difference, because if our 18 is in this corner, 8 is our opposite. But if our 18 is in this corner, now 8 is our adjacent. So it does make a difference. Bottom line, the 18's got to be in this corner, okay? When we do that, now that we've got our drawing, it's a quick, what is it, 2-step, 3-step, just like it has been. Out here, 8 is the opposite. Down at the bottom, X is the adjacent. And we're using, like I said, a lot of times it's going to be tangent because hypotenuse is kind of weird. Opposite, adjacent, that's tangent. The tangent of 18 is equal to the opposite 8 divided by the adjacent X. And you go to Desmos, you type it in. Tangent 18 equals 8 divided by X. It's not going to tell me the answer, so I got to do backspace and put the X all the way at the front. Now it's going to tell me 24.6. Cool. X equals 24.6. And what is 24.6? It's how far away he is, and we're talking about feet. Oh, let me go back so you can see. 24.6 feet. Okay. Again, we maybe talked about it to the point that it made it seem long and confusing. We just got to draw a triangle and then type it in Desmos. The pilot in a helicopter spots a landing pad below. This is fantastic, right? I got to draw a helicopter. The trick to drawing a helicopter is you kind of do like one of these, right? Once you draw one of those, boom, Easy. Got it. Helicopter. Not too bad, not too bad. All right. So our helicopter is nice and up here. He's going to spot a landing pad down below. So, of course, you know, a helicopter landing pad, what? It's a big capital H. Something like that. I don't know. I'm doing my best. And the drawing stuff, whatever. You don't have to do the drawing stuff. What you got to do is put a 73 on this picture somewhere. You got to put a 1200 on this triangle somewhere, and you got to put an X on this triangle somewhere. So where's everything going? 73. If you imagine that he's supposed to be looking straight, and then he looks down 73, that means the 73 doesn't go by the helicopter. The 73 actually goes by the helipad. So we put our 73 down there by the helipad. Okay. Thanks very much. All right. And we've got a nice little helipad here. Things are looking good. We got to put 1200 on there somewhere. The horizontal distance to the pad is 1,200 feet, 1,200. So where's that 1,200 going? Well, it needs to be a side. So it can't be. It's either gonna be how high in the air is the helicopter. It's gonna be how far is the helicopter from straight down all the way to the helipad. That's kind of a weird thing. Or it's the actual distance from the helicopter straight to the pad. It says the horizontal distance. That's a pretty important word. Horizontal means side to side. And I have heard a couple people say it. That means 1,200 or 1,200 should be this bottom side here. So then the question says, what is the altitude of the helicopter? Mr. Collier, A1? Sure. Yeah. Daily shit. That was a call for you to be dismissed. So we've got an X, and it's talking about the altitude. I hope that you took your, helicopter vocab course in order to complete this question. Altitude. Is altitude this how tall the helicopter is in the sky, or is the altitude the hypotenuse? Right. The altitude should be this high. How high up is it flowing? How flying? Floating, flying, whatever. They kind of do both, I guess. All right, let's make our little equation here. I see the 73, which is in this corner. I'm doing my best, man. Oh, yeah. I mean, listen. The helicopter is probably way up in the sky. 1,200 feet. Is that the opposite adjacent hypotenuse? That's the adjacent. Okay. Over here, this X, the altitude, is that the opposite or the hypotenuse? Right, and we're using tangent again. Boring, but whatever. Tangent of 73 is equal to the opposite. We're going with X divided by 1,200. I agree. These are big numbers that we're working with. We're probably zooming out trying to find it. Tangent 73 is equal to X over 1,200. Whew, there it is. I got 3,925 feet in the air with a 0.02. It's not going to round up. It's going to stay 0.0. And you know what? I don't even have to write 0.0. So I'm going 3,925 feet in the air. All right, we are right on time. We're going to finish right before lunch. Let's do one more question just to wrap this up, and we're going to go a lot faster. We don't have a picture. Let's see what we're working on with this one. Zach is standing at the top of a lookout tower and spots a water fountain below. What a strange question. Let's draw our triangle here. Zach is on the top of a lookout tower. We'll just make this look like a tower. Cool, good enough. And he spots a water fountain below. You think it's one that you drink out of, or you think it's like a fun one that kind of...
One that has ducks in it.
One that has ducks. Look, there's a duck in there. All right. The lookout tower is 75 feet tall, and the angle of depression is 28. I do want to check to see if there's any talk about how tall Zach is or something, but there's not, right? The only numbers we get is 75 feet tall, 28 degrees. So I know that lookout tower, 75 is going right there. 28 degrees, you can assume Zach is looking straight, but then he tilts his head down 28, and so the actual 28 goes in this corner. What is the horizontal distance between Zach and the water fountain? I need to know how far away he is. Again, surprise, surprise. We're going to want to use tangent like we always seem to end up using. The opposite and the adjacent. Tangent 28 is equal to opposite 75 over adjacent x. This one is not going to work in Desmos, so I got to move that x to the front. Tangent 28 equals 75 divided by x. There it is. Doesn't work. Backspace, move it to the front. Click it. 141.1 I heard, and that is correct. X equals 141.1 feet. For the most part, angle of elevation, angle of depression is pretty much the same setup. Draw a little triangle. For depression, the one trick is don't end up putting it in that top corner, because the actual angle of depression, blah, 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 it ends up down here. All right.